in the unit. So we're going to quickly review everything we've learned in the unit, but it's going to be really quick. So I need you to just look up here with your eyes to start out with, and just a reminder of what we've learned so far. So the first thing we learned in this unit is how to graph a quadratic. So it's in standard form, ax squared plus bx plus c. It's got to be set equal to 0, right, everybody? Then to find your axis of symmetry, you use the formula x is equal to the opposite of b over 2a. Then once you know your axis of symmetry, you draw in your dotted line, and then your vertex, you'll plug in that x value into your function, and that will give you your y value. Right, everybody?
Yeah.
Okay, so then y-intercept is always when x is equal to?
0.
0. So you plug in 0 into your function, that's what's crossing the y-axis. Then we've learned many different ways to find zeros, which is where it's crossing the x-axis. So, we learned this the other day. If it's crossing the x-axis twice, that would give us 2 real solutions. If it's crossing the x-axis once, where it bounces and goes back up, we get how many solutions? 1, and it's going to be real if it touches the x-axis. Now, if you have a parabola that looks like this, never crossing the x-axis, we still have 2 solutions, right? Don't all quadratics have 2 solutions? They're just going to be what kind of solutions? Imaginary. Okay, sweet. So we've learned how to find all these x-intercepts, these solutions, by these different methods. We learned how to solve when missing bx, right? What would we do?
By plus 4.
Plus 4?
Divided by 2.
Divide by 2, then take the? And not forget the? Not forget the plus and minus. Very good.
Yeah.
Okay, so any questions on solving when missing bx? Okay, we learned how to solve by factoring. You make sure it's at equal to 0, then we do a multiply to be a times c, adds up to be b. We factor. But once you factor, are you done? No, what do we do?
Plug it in.
You're on the right track. What do we do once we factor, guys? Well, once we've factored it, that's part of factoring.
You put it equal to 0 and then solve.
Perfect. We set our factors equal to 0 and solve. Can anyone remember the rule that allows us to break it up? Yeah. Beautiful. Way to remember that. The zero product property. Okay, so we can solve by factoring. Then we also learned how to solve when completing the square. So we took our quadratic from standard form to vertex form. Then we set it equal to 0 and solve. Remember, to complete the square, we take b divided by 2 squared. I noticed a lot of you on the quiz tried to solve by completing the square when I said solve by factoring. So if I say solve by factoring, I expect you to factor. Okay, and then we finally learned the quadratic formula, and the quadratic formula will always work when solving a quadratic no matter what. Let's sing our song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Good. Way to remember that. Alright, I just didn't want you to forget everything we've learned so far. Add to today's lesson, 6-8. So today's 6-8, we're going to be learning about complex numbers. So complex numbers, the first thing you need to understand about complex numbers is they have this form, a plus bi. Now understand, a is the real part, bi is the imaginary part. We've already been seeing solutions like this with quadratics. So remember how some of us are writing our answers like this, 2i plus 7. And remember how I was like, I'm going to be a stickler and make you rewrite it so that the real part's first? Do you remember me saying that? So we would rewrite this as what? 7 plus 2i. Now here's why. Because once again, a complex number has the form a plus bi, where a is the real part, such as 7, and bi is the imaginary part, such as 2i. Questions on that? Okay, so we're going to be adding and subtracting, first of all, complex numbers. So we're going to take 2 complex numbers and we're going to add them together. We're going to take 2 complex numbers and subtract them. So, when adding or subtracting complex numbers, you can only combine real numbers with real numbers. So you'll combine the real part with the real part. You can only combine imaginary numbers with imaginary numbers. So you'll combine the imaginary part with the imaginary part. So really, it's pretty easy to start out with. We know how to combine like terms. We've been practicing this all year. So you can only combine like parts. Real parts with real parts, imaginary parts plus imaginary parts. Does everybody understand what I'm saying? Just like x plus x is combining like terms, right? 2x. Questions on that? Okay, here's our first example. So we have 2 complex numbers. It says negative 2 plus 3i. This is a complex number, guys, a plus bi. We're adding another complex number, a plus bi. Does everybody see how I'm adding two complex numbers? Now pay attention to this. Most common mistake is students see the parentheses and they automatically start multiplying and distributing. Distributing is a multiplication property, right? Now look, with your eyeballs, isn't that a plus sign? So we won't multiply, we're adding these complex numbers. So let's go ahead and do that. So you combine the real parts with the real parts. So negative 2 plus 4 is?
Negative, 4. 2.
2, right? Negative 2 plus 4, guys, is 2. And then 3i plus negative 5i is how many i's? Negative 2 i's. Very good. And we're done. We've combined all the real parts with the real parts, the imaginary parts with the imaginary parts. Questions? Pretty easy. Okay, let's do another one. We have 2 plus 7i plus 8i. Are we multiplying these things? Nope. Once again, we see the addition sign. We know we're adding. So don't let it throw you off, guys. Real parts with real parts. 2. Do you see any other real parts? Nope. So we have a 2. Then 7i plus 8i. 15. 15i. So plus 15i. Questions? Okay. Now here's where we have to be oh so careful. Dun dun dun. Subtraction. Yikes. This is the one where most students miss. 9 out of 10 students miss it. Let's not do that, okay? So first of all, with subtraction, aren't we subtracting all that stuff? So don't we have to distribute the negative through? So mathematically, what we're doing here is we're multiplying negative 1 through, right? Remember how I taught you to do that with subtraction?
Yeah.
So let's do that so we don't make any errors. Negative 1 times 3.
Negative 3.
Negative 3, very careful here. Negative 1 times positive 2i.
Negative 2i.
Negative 2i. Now the nice thing is we've taken care of the subtraction sign. And now this front part we can just drop down. Negative 2 minus 7i. Questions on distributing that negative through? We're not going to miss it today. Okay, let's combine like terms from here. Negative 2 minus 3. Negative 5, very good. And negative 7i's minus 2i's. Minus 9i's. Very good. And it's in the form a plus bi. Questions? One more subtraction and then I'm going to let you work. Okay? One more subtraction then I'm going to let you go. So stay with me. 4 plus 2i minus negative 7 minus 3i. Once again, subtraction. We have to be very careful. So once again, mathematically, what we're technically doing is putting a negative 1 here. Distributing it through. Negative 1 times negative 7. Positive 7?
Yep.
Negative 1 times negative 3i's. Positive 3i's. And now we've taken care of the negative, and now we can just drop down the front. 4 plus 2i. Then from there, we'll just combine like terms. 4 plus 7. 2i's plus 3i's.
5i.
Plus 5i's. So guys, oh yeah, one last thing. Questions on that? I didn't do this first hour and it was a mistake. We're going to simplify these, even though I truly feel in my heart like you should be able to. The square root of negative 64. Don't say that's negative 8. You're wrong.
8.
Good. You guys knew it better than first hour. So remember that negative 64 is the same thing as 64 times negative 1. Then we break it down in pieces. What's the square root of 64? 8. What's the square root of negative 1? I. So 8i is our answer. Okay, what about this one? I rewrite this one as 27 times negative 1. And then if you try to do the square root of 27 on your calculator, you get a decimal. So you know you have to break it down by hand. 9 times
30.
9 breaks down into,
3 times 3.
and then we pull out groups of 2. So we can pull out do we pull out a 9? No, we pull out a 3, right? And then this is left underneath the radical, right?
Right.
And then we're pulling out negative 1, and there's a, so we pulled out a 3i, and left was the square root of 3. Questions on how to simplify square roots, guys? Yeah.
It's 7.
Then can you pull it out? No. So you'd leave the 7 underneath, but what will you pull out?
Oh, is it just square root 7?
Beautiful. You're absolutely correct. So do these problems, 1 through 6. I want you to completely cross out 7 through 9, and then you're doing 10 through 13, and then check with me, and then we'll move on. Oh, crap, I didn't know. I got to put that on my recording. So we know I squared is equal to -1, so we've got to have that memorized. Okay, here we go. So let's distribute. We're doing this complex number multiplied by this complex number. So what's 2 times -2? -4. 2 times -4i. -8i's. Very good. And then with this one, 2i times -2. What do we get?
-4i.
Awesome. Not making any sign errors. 2i times -4i. Careful.
I squared.
Awesome. Way to not forget that. That would be I squared. Does everybody see why I times I is I squared?
Yeah.
Okay, awesome. So now this is where we go off to the side and say, we know that I squared is equal to what?
1.
-1. So really, looking up here, don't we have -8 times I squared? Isn't that the same thing as -8 times -1? Does everybody see how I did that? Does it make sense? Okay. What's -8 times -1? +8. Okay, awesome. So I'm going to rewrite this. We have -4 minus 8i minus 4i plus 8. And now we're simply combining like terms. So real parts with real parts, imaginary parts with imaginary parts. What's -4 plus 8? Okay, let's be really careful. Let's think about it again. So I want you all to think about it again. What's -4 plus 8? 4. Right, everybody? And then what's -8i plus -4i's? -12i's. Very good. Did everybody see how to do that one? Okay, we need to see one more. Guys, these are the hardest ones. Let's do another one. Group 1, you guys need to be watching. So we have 2 minus I squared. Now, question for you. Can I just square that, square that? That would be breaking the first forbidden rule I ever gave you in this class to begin with at the beginning of the year, right? Just squaring this, squaring this. Okay, so how will we rewrite this?
2 minus I. 2 minus I.
So 2 minus I times 2 minus I. Very good. Now, let's distribute. You know what? I'm going to let you try it. Go. Try this one very carefully. And then I'm going to come see if you got it right. And then we'll go through it together. Okay, ready, set, go. I'll try it. Let's go through this. Okay, look, everybody carefully. 2 times 2.
4.
2 times -I. -I times 2. And then -I times -I.
I squared. No, I squared.
Positive I squared, right, everybody? Do you see how much room there is for error here? So then we say, I know that I squared is equal to -1. So really we have 4 minus, let's just combine these while we're here. What's -2i minus 2i? -4i. And then we have plus, what? Plus -1. Or just -1, same thing, Braylon, right?
And what about that would just be plus that's 4 hours. No.
This isn't an I squared is equal to -1, right?
You could
Then combine like term. Yeah, you can't combine an I squared with an I. Just like you can't combine x squared plus x, right? So then we combine like terms. 4 plus -1.
3.
Positive 3, guys. 4 plus -1 is 3. And then we have -4i. Do you see how I did that?
Yeah.
Do you see how much room there is for error? So careful. Okay, one more. Hardest one.
Hardest one?
Now, I had somebody actually get this on the ACT. They brought me a question very similar to this on the ACT and said, how the heck do I do that? And I said, oh, I'll teach you. So everybody look up here. We have 2i times 5i times -3i. Now, it's not a form of a binomial. This just has one term, one term, one term. So we're just multiplying it together. So what's 2 times 5 times -3? Let's look at it in pieces. What's 2 times 5? 10. What's 10 times -3? -30, but it's multiplication, right?
Yeah.
What's I times I times I?
I cubed.
I cubed, right? But now here's the trick. Think about it. We know that I squared is equal to negative 1. So we need to rewrite it anytime it's higher than 2 in terms of degree 2. So let's rewrite this. Isn't this negative 30 times I squared times I? Look, I squared times I. Isn't this I to the first?
Yeah.
Isn't this 3? So do you see how I rewrote it in degree 2? Because we know I squared is equal to negative 1. So we have negative 30 times negative 1 times I to the first, which is just I. So what's negative 30 times negative 1? 30. And then left is a I. So guys, what if I gave you this on the test? I to the 7th power. Isn't that I squared times I squared times I squared? That's 2, 4, 6.
Plus 1.
And then I, right? To the first. Do you see how I rewrote it in degree in 2, in terms of 2? So we would have negative 1 times negative 1 times negative 1 times. So what's negative 1 times negative 1?
Positive 1.
1 times negative 1.
Negative 1.
Negative 1 times I.
I.
Negative 1I, right? So do you see how you can do these? You will run into it on the ACT. Not a hard problem as long as you know I squared is equal to negative 1. Okay, sweet. So now I want you to do 14 through 19. You guys, be careful. Please, I'm begging you to not make the same error. See, guys, I'm going to do 22 with you. Here we go.
Okay.
So looking at it, we have negative 5 plus the square root of negative 4 minus 3 minus the square root of negative 6. So first of all, these are complex numbers in disguise. So first of all, in the parentheses, what I really have is negative 5 plus, what's the square root of negative 4?
Negative 2.
No, you're wrong. You know better than that. What is it? 2i. Very good. Does everybody understand what I did there? And then it's minus, we have 3 minus, what's this square? I'm just looking at this piece. What is that?
8i.
No, the square root of 16 is?
4i.
4i. So you see how I rewrote them?
No, you don't. You can do it after.
Are we all good?
Yeah.
Now it was subtraction. So everybody watch very carefully. We're going to put a negative 1. A lot of you messed this up royally. So everybody, negative 1 times 3.
3. Negative 3.
Negative 3. You're not going to double dip and put another negative in front.
Right.
That's what some of you are doing. Negative 1 times negative 4i.
4i.
Positive 4i. Okay. So then from there, we've already distributed the negative through. Now you just drop down the front thing. Negative 5 plus 2i. And from there you'll combine like terms. Negative 5 minus 3.
Negative 8.
And then positive 2i plus 4i.
Plus 6i.
Okay, very good. One more like that from the worksheet.
Wait.
Okay, I'm going to do 27. So we have 5 plus the square root of negative 1 times 2 minus the square root of negative 36. They're complex numbers in disguise, so rewrite them. So this is 5 plus, what's the square root of negative 1? I. And then we have 2 minus, what's the square root of negative 36? 6i, right, everybody? Then from there, we're going to distribute combine like terms. 5 times 2 is positive 10. 5 times negative 6i is negative 30i's. A lot of you are just messing up on this. I times 2 is positive 2i's. I times negative 6i is negative 6. You'll not forget I times I is I squared. So really, I have 10 minus, I'm going to add those up, and what do you get?
32. Wait, 28.
What's negative 30 plus 2?
Negative 28.
Negative 28i. And then I have negative 6 times I squared. So don't I really have negative 6 times negative 1? Which is positive 6, right? So then I'm going to combine my terms. 10 plus 6 is 16. So we have 16 minus 28i. Questions on how to do these? Don't mess up on this part is where people are messing up for some reason. They were forgetting a plus, like plus versus subtraction is very different. So you gotta make sure you put in the right things. Okay, I need you to finish the front of the worksheet. It's due by tomorrow, the whole front. But you need to have them correct.
Yeah.
So you have just over 10 minutes to check your answers with me.